discussion regarding the use of conduits and motor controllers on all municipal pools and spa centers primarily around enhancing safety and boosting energy efficiency. Conduits serve as protective pathways for electrical wires, shielding them from potential damage and moisture. In numerous regions, electrical codes mandate the use of conduits for all electrical installations, encompassing those within pools and spas. Motor controllers are devices designed to manage the speed and power of electric motors. Their integration can lead to improved energy efficiency by curtailing the power consumption of the motor. The employment of conduits and motor controllers across all municipal pools and spas yields several advantages. Firstly, improved safety is achieved. Conduits and motor controllers play a role in preventing electrical shocks and fires. Secondly, there is increased energy efficiency. Motor controllers contribute to reducing the power utilized by pool and spa motors, translating to savings on energy expenses. Thirdly, extended equipment life is attained. Conduits and motor controllers offer protection to pool and spa equipment, thereby prolonging their operational lifespan. While the initial investment in installing conduits and motor controllers may appear substantial, the long-term benefits can outweigh the costs. Furthermore, various government rebates and incentives are often accessible to alleviate the financial burden associated with these installations. If you are contemplating the installation of a new pool or spa or planning to upgrade an existing one, the consideration of conduits and motor controllers is advised. These components have the potential to enhance safety, elevate energy efficiency, and extend the lifespan of your pool or spa equipment. Electrical safety in and around pools and spas is a critical concern. The presence of water combined with electrical equipment creates a heightened risk of electrical shock. Ground fault circuit interrupters, or GFCIs, are essential safety devices that detect even small imbalances in electrical current and quickly cut off power to prevent shocks. Regular inspection and testing of GFCIs are crucial to ensure they are functioning correctly. Bonding is another important safety measure. It involves connecting all metal parts of the pool or spa system, including the water, to create a common electrical ground. This helps to prevent voltage differences that could cause shocks. The National Electrical Code, or NEC, provides detailed guidelines for electrical installations in pools and spas. It covers everything from wiring methods to equipment placement to grounding and bonding requirements. Adhering to the NEC is essential for ensuring the safety of swimmers and bathers. Motor controllers play a vital role in optimizing the performance and efficiency of pool and spa motors. They can be used to control the speed of the motor, allowing it to operate at the most efficient level for the current conditions. Variable frequency drives, or VFDs, are a type of motor controller that can precisely adjust the motor's speed to match the demand. This can result in significant energy savings, especially for larger pool and spa systems. Soft starters are another type of motor controller that can reduce the stress on the motor and electrical system during startup. They gradually increase the voltage applied to the motor, preventing sudden surges of current. This can extend the life of the motor and reduce the risk of electrical problems. Proper ventilation is important for electrical equipment in pool and spa areas. Enclosures should be designed to allow for adequate airflow to prevent overheating. Overheating can damage electrical components and create a fire hazard. Regular maintenance of electrical equipment is essential for ensuring its safe and reliable operation. This includes inspecting wiring, connections, and components for signs of wear or damage. Any problems should be addressed promptly by a qualified electrician. In addition to conduits and motor controllers, other safety measures can be implemented to further reduce the risk of electrical hazards. These include using low-voltage lighting, installing safety switches, and providing clear signage. Education is also important. Pool and spa owners should be aware of the potential electrical hazards and how to prevent them. They should also know how to respond in the event of an electrical emergency. Staying informed about the latest electrical safety codes and standards is crucial for ensuring the safety of pools and spas. The NEC is updated regularly to reflect new technologies and best practices. Pool and spa professionals should stay up to date on these changes and implement them in their work. Conduits offer several advantages when used in electrical installations, particularly in wet or corrosive environments like those found around pools and spas. Firstly, physical protection is provided. Conduits shield electrical wiring from physical damage, such as impacts, abrasion, and crushing. This is especially important in areas where there is heavy foot traffic or where equipment is moved around. Secondly, environmental protection is given. Conduits protect wiring from moisture, chemicals, and other corrosive substances. This helps to prevent corrosion and degradation of the wiring, which can lead to electrical problems. Thirdly, safety is enhanced. Conduits provide an additional layer of safety by containing any potential electrical faults. If a wire becomes damaged and shorts out, the conduit will help to prevent the spread of fire and protect people from electrical shock. Fourthly, organization is improved. Conduits help to organize and manage electrical wiring, making it easier to install, maintain, and troubleshoot. They also provide a neat and professional appearance. There are several different types of conduits available, each with its own advantages and disadvantages. Rigid metal conduit, or RMC, is a heavy-walled conduit made of steel or aluminum. It provides excellent physical protection and is suitable for use in harsh environments. Intermediate metal conduit, or IMC, is a thinner-walled conduit made of steel. It is lighter and less expensive than RMC, but still provides good physical protection. Electrical metallic tubing, or EMD, is a thin-walled conduit made of steel or aluminum. It is lightweight and easy to install, but it does not provide as much physical protection as RMC or INC. Flexible metal conduit, or FMC, is a flexible conduit made of steel or aluminum. It is used in situations where the conduit needs to be bent or routed around obstacles. Liquid-type flexible metal conduit, or LFMC, is a flexible conduit that is covered with a liquid-type jacket. It is used in wet or damp locations. The choice of conduit depends on the specific application and the level of protection required. Factors to consider include the environment, the type of wiring being protected, and the budget. Motor controllers offer a range of benefits for pool and spa motors, including energy savings, extended motor life, and improved performance. Firstly, energy savings are seen. Motor controllers can reduce the energy consumption of pool and spa motors by optimizing the speed and torque to match the demand. This can result in significant savings on energy bills, especially for larger systems. Secondly, motor life is extended. Motor controllers can reduce the stress on motors during startup and operation, which can extend their lifespan. They can also protect motors from overloads and other electrical problems. Thirdly, performance is improved. Motor controllers can improve the performance of pool and spa systems by providing more precise control over the motor's speed and torque. This can result in better water circulation, filtration, and heating. There are several different types of motor controllers available, each with its own features and capabilities. Firstly, across-the-line starters are simple devices that apply full voltage to the motor at startup. They are the least expensive type of motor controller, but they can cause high inrush currents that can stress the motor and electrical system. Secondly, reduced voltage starters reduce the voltage applied to the motor during startup. This reduces the inrush current and stress on the motor. There are several different types of reduced voltage starters, including auto-transformer starters, part-winding starters, and Y-delta starters. Thirdly, variable frequency drives, or VFDs, are the most advanced type of motor controller. They can precisely control the motor speed and torque by varying the frequency and voltage of the power supply. This allows for optimal energy savings and performance. The choice of motor controller depends on the specific application and the desired level of performance and energy savings. Factors to consider include the motor size, the load characteristics, and the budget. When installing conduits and motor controllers, it is important to follow all applicable electrical codes and standards. This will ensure that the installation is safe and reliable. It is also important to use qualified electricians who have experience with pool and spa electrical systems. Regular inspection and maintenance of conduits and motor controllers are essential for ensuring their continued safe and reliable operation. This includes checking for signs of wear or damage and addressing any problems promptly. By taking these steps, pool and spa owners can help to ensure the safety and efficiency of their electrical systems. The National Electrical Code, or NEC, Article 680 covers the requirements for electrical installations in swimming pools, spas, hot tubs, and similar installations. This article provides detailed guidelines for wiring methods, equipment placement, grounding and bonding, and other safety measures. It is essential to comply with NEC Article 680 when designing and installing electrical systems for pools and spas. Grounding and bonding are critical safety measures for pools and spas. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. Bonding connects all metal parts of the pool or spa system to create a common electrical ground, which helps to prevent voltage differences that could cause shocks. The NEC requires that all metal parts of the pool or spa system, including the water, be bonded together. This includes the pool shell, the metal reinforcing bars, the metal piping, pump motor housing, and any other metal equipment that is within reach of a person in the water. The bonding conductor must be sized according to the NEC and must be connected to a grounding electrode. Ground fault circuit interrupters, or GFCIs, are required for most electrical circuits in pool and spa areas. GFCIs detect even small imbalances in electrical current and quickly cut off power to prevent shocks. The NEC requires that all receptacles within a certain distance of the pool or spa be GFCI protected. It also requires that certain equipment, such as pool pumps and heaters, be GFCI protected. Wiring methods for pools and spas must comply with the NEC. The NEC specifies the types of wiring that are permitted in different locations around the pool or spa. Underground wiring must be buried at a certain depth and must be protected from physical damage. Wiring above ground must be installed in conduit or other approved raceway. Equipment placement is also regulated by the NEC. The NEC specifies the minimum distances that electrical equipment must be located from the pool or spa. This is to prevent people from accidentally coming into contact with energized equipment while in the water. Overcurrent protection is required for all electrical circuits in pool and spa areas. Overcurrent protection devices, such as circuit breakers and fuses, protect the wiring from damage caused by overloads and short circuits. The NEC specifies the size of the overcurrent protection devices that are required for different circuits. Inspections are an important part of ensuring the safety of pool and spa electrical systems. A qualified electrical inspector will inspect the installation to ensure that it complies with the NEC and other applicable codes. Any deficiencies must be corrected before the pool or spa is put into use. Regular maintenance is essential for ensuring the continued safe operation of pool and spa electrical systems. This includes inspecting wiring, connections, and equipment for signs of wear or damage. Any problems should be addressed promptly by a qualified electrician. By following these guidelines, pool and spa owners can help to ensure the safety of their electrical systems. The NEC provides specific requirements for the location of receptacles around pools and spas. Receptacles must be located at least 6 feet from the inside wall of the pool or spa, unless they are GFCI protected. Receptacles that are located between 6 and 10 feet from the inside wall of the pool or spa must be GFCI protected. Receptacles that are located more than 10 feet from the inside wall of the pool or spa do not need to be GFCI protected, unless they are serving pool equipment. The NEC also specifies the type of receptacle that must be used in pool and spa areas. Receptacles must be of the grounding type and must be protected by a weatherproof cover. The NEC requires that all underwater lighting fixtures be listed and labeled for use in swimming pools. Underwater lighting fixtures must be installed in accordance with the manufacturer's instructions. Underwater lighting fixtures must be located at least 18 inches below the water level. Underwater lighting fixtures must be GFCI protected. The NEC provides specific requirements for the grounding and bonding of pool and spa equipment. The equipment grounding conductor must be sized according to the NEC and must be connected to the grounding electrode. The bonding conductor must be sized according to the NEC and must be connected to all metal parts of the pool or spa system, including the water. The NEC requires that all pool and spa equipment be accessible for inspection and maintenance. Equipment must be located in a well-ventilated area and must be protected from the weather. Equipment must be installed in accordance with the manufacturer's instructions. The NEC provides specific requirements for the wiring of pool and spa equipment. Wiring must be installed in conduit or other approved raceway. Wiring must be sized according to the NEC. Wiring must be protected from physical damage. The NEC requires that all pool and spa equipment be properly labeled. Equipment must be labeled with the manufacturer's name, model number, voltage, and amperage. Equipment must be labeled with the date of installation. By following these guidelines, pool and spa owners can help to ensure the safety and reliability of their electrical systems. The integration of variable frequency drives, or VFDs, into pool and spa systems represents a significant advancement in energy efficiency and operational control. VFD enable precise adjustment of motor speed, allowing for optimal performance under varying conditions. This technology offers substantial benefits, particularly for large pool and spa installations where energy consumption is a major concern. Firstly, energy conservation is seen. VFD optimize motor speed to match the actual demand, reducing energy waste during periods of low usage. This can lead to considerable savings on electricity bills over time. Secondly, extended equipment longevity is attained. By controlling motor speed, VFD minimize stress on the motor and connected equipment, extending their lifespan and reducing maintenance costs. Thirdly, enhanced system performance is observed. VFD provide precise control over water flow, filtration, and heating, resulting in improved water quality and a more enjoyable user experience. Fourthly, noise reduction is achieved. Slower motor speeds reduce noise levels, creating a more peaceful and relaxing environment around the pool or spa. Retrofitting existing pool and spa systems with VFD is a viable option for those seeking to improve energy efficiency and performance. The initial investment in VFD technology can be offset by the long-term savings on energy costs and reduced maintenance. Furthermore, many utility companies offer rebates and incentives for installing energy-efficient equipment, making VFD an even more attractive investment. When selecting a VFD for a pool or spa system, it is important to consider the motor size, voltage, and current requirements. The VFD must be properly sized to handle the motor's load and must be compatible with the existing electrical system. It is also important to choose a VFD that is designed for use in wet or humid environments. Installation of a VFD should be performed by a qualified electrician who is familiar with pool and spa electrical systems. The electrician will ensure that the VFD is properly grounded and connected to the motor and electrical system. The electrician will also program the VFD to optimize its performance for the specific application. Regular maintenance of VFDs is essential for ensuring their continued safe and reliable operation. This includes checking for signs of wear or damage and addressing any problems promptly. It is also important to keep the VFD clean and free from dust and debris. By taking these steps, pool and spa owners can maximize the benefits of VFD technology and ensure the long-term performance of their systems.